Engineering Mechanics Statics, lecture number 6. Today's objective is student will be able to use the dot product to determine an angle between two vectors, determine the projection of a vector along a specified line. From the last class, we already learned about Cartesian vectors, position vectors, and now we are going to learn about dot products. So Cartesian vectors, the location of force is like this. Let's say if there is a cable here and you apply a force here. So simply you want to find the force in a Cartesian vector forms. You might need to project the force into each of the axes x, y, and z, and find the Cartesian vectors in each of the axes. Let's say like this. This is for Cartesian vectors. For position vector, if let's say you have a pole like this, or truss, or cable like a change or anything, and then you apply force here, so the object here, you need to find the radius first, or the length of the radius. So this radius we can change to form the Cartesian vector forms. So if you want to integrate with the force here, so you need to do the multiplication. So you need to multiply the force with the unit vector. Unit vector is a Cartesian form of RAB over the magnitude or length of the RAB. So this is the unit vector. So for dot product, if you have the pole like this, and the pole is attached to the cable like this, and the cable is apply force like this, so we have this situation, we have two vectors, which is the vector for R and then the vector for F, like this. Like this case, this is only one single vector, which is the R, and this one is one single vector, which is F. So for dot product case, you have two vector, which is R, and this cable which attached with the force. Okay. So the first vector is ROA, xi plus yj plus zk. And then you can also have both. This is the vector and this is the scalar. And then the force here also have their own. The force here have its own vector form. And then you can get the magnitude. This is the scalar and this is the vector form. Okay. So if you do the dot product, other than the product is a cross product. This is the way how you multiply between two vectors. Okay. So if you do the dot product, so you can get the angle between the two vectors, and then the scalar magnitude of both of the vector between F and R. Okay. Okay, let's look at some theories about dot product here. If you have two vectors, which is A and B, this is equal to vector A, B cosine theta, normally between force F and distance R. Okay. Angle theta is the smallest angle between two vectors and is always in a range of 0 degree to 180 degree. This is the characteristic of dot product. The result of dot product is a scalar, which is only magnitude. So remember that when you perform the dot operation, so your answer must be in scalar form or magnitude form, not in a vector form. The unit of the dot product will be the product of the unit of the A and B vectors, vector in magnitude and direction. Please remember this one. If we dot product between two vectors, which is A and B, so the operation might be like this. Should be like this. AX multiply with BX, AY multiply with BY, AZ multiply with BZ, AX BX plus AY BY plus AZ BZ. Thus, to determine the dot product of two Cartesian vectors, multiply their correspondingly x, y, z component and sum their product algebraically. Okay, let's see this. Here is some equation that you need to remember. Okay, which is theta is equal to cosine inverse A dot B over AB. Okay, so it is starting from here, finding the dot product of A dot B, which is using this equation AX BX plus AY BY plus AZ BZ, and then finding the magnitudes of A and B of the vectors A and B, and using the definition of dot products, solving for theta. Okay, this is the definition of dot product, which is cos theta is equal to A dot B over AB. A dot B is a scalar magnitude over magnitude for A multiplied with magnitude for B. Okay, so for case like this, if you want to find the theta here, so using the same equation, theta is equal to cosine inverse, and then the dot product here is between F and R. So F dot R, ROA, over the magnitude for F and the magnitude for ROA. So over here is a vector of F dot product with vector of ROA over the magnitude of R multiplied with magnitude of ROA. So please remember this. If you want to find the force for the force of O to A, or we might say that the whole force of the systems, so the equation is like this: FOA equal to F cos theta. Theta you can get from here. Okay. Or also you can use this equation: FOA is equal to the vector of F, which is here, dot product with the unit vector of ROA. So you also get the value of FOA. Now let's do some example here. Okay, if you have the system like this, this is the pole attached to the wall here, and then the axis is placed here between the pole and the cable, the attached cable. Okay. So the force is acting on the pole. Okay, the force is acting on the pole. So the question is to find the angle between the force vector and the pole. So you need to find the angle between the vector of pole and the vector of F. Okay. And the magnitude of the projection of the force along the pole OA. Okay, so if we apply force here through the cable, so what is the force of the whole system, or the force that we can call it the projection force along the pole O to A. Okay, so what you need so first what you need to do is to get the ROA. Okay, find the vector of the ROA here, and then the vector of F is already given here. So, and then do the operation using the equation that we discussed just now, which is theta is equal to cosine inverse F here is a vector of F, then you dot product with the vector of ROA, divide by the magnitude of F multiply with the magnitude of ROA. So if you want to calculate the force of the whole system, or we can call it as a projection force of O to A, or we denote as a FOA, we can calculate by using the operation of dot product between vector of F and vector of univector for ROA. Okay. First find the vector for ROA. So you have two coordinate here. The first coordinate is at the origin 0, 0, 0, and the second coordinate is at A. So imagine here this is A, okay, denote as A. Okay, what the coordinate for A here? So the coordinate is over here. For the x-axis is 2, y-axis is 2, and the z-axis is negative 1 because the direction is downward. Okay, so so you have two coordinate 2 to 1 and 0, 0, 0. So using the equation of how to find the ROA, so you will get the vector for ROA is 2i plus 2j minus 1k. Okay, this is the vector of ROA, and then the scalar is square and square root, so you get 3 meter. The vector for F is given 2i plus 4j plus 10k kilonewton, and then find the magnitude of the force here, square each of the component and square root. You will get the magnitude of force is 10.95 kilonewton. Okay. So if you want to find the angle between those two vectors, so using this equation, theta is equal to cosine inverse F dot product with the ROA. So your F vector is this one, your R vector is this one. Do the dot product operation. Okay, the dot product operation is equal to, if still remember, I multiply with I, j multiply with j, and k multiply with k. So this become like this: 2 multiply with 2, 4 multiply with 2, and 10 multiply with -1. So keep in mind that dot product operation will produce a scalar or a magnitude, not a vector. Remember that. Okay, the answer is 2 kilonewton meter. Okay. And then substitute into this equation. So your F here is a magnitude of force here, which is 10.95 kilonewton, and then your ROA, and then your magnitude of ROA is a 3 meter. So magnitude, so substitute into the equation. Okay, so we'll get equation like this: 2 over 10.95 multiplied with 3, inverse cosine this operation, then you will get the angle is equal to 86.5 degree. So angle here is about 86.5 degree. Okay. And then the question asks you to find the force of the whole system. How much the force of the whole system? So for this problem, you can only get the force in the form of magnitude or scalar, because we do the operation of dot product. So to find the force of the whole system, or we can call it as the projection force on the pole of OA or FOA, so you need to use this equation. There are two ways actually. You can use this equation or you can use this method. Okay, so first let's look at this method. So FOA is equal to the vector form of force dot product with the unit vector of OA. So this unit vector is actually a unit vector for ROA, vector of ROA over the magnitude of ROA. So your vector ROA is this one, 2 minus I, 2I plus 2j minus 1k, divide with the magnitude of ROA, which is 3 meter. So divide each of the component with 3. So you will get the unit vector of the UOA is like this. Okay, and then use this unit vector, form the operation of dot product with the vector of F. So those two vectors of F and UOA, when you do the dot product, so you're gonna get the scalar magnitude of the force of FOA. Okay. So to do the dot product, please remember the equation, which is for I, you need to multiply with the I component. The I component of F multiply with the I component of UOA, and J component of F multiply with the J component of the unit vector, which is this one, and so forth. So the answer is 0.667 kilonewton. So the whole force of the system is 0.667 kilonewton, and the effect is on the pole here. So that's why we call it as a projection force of FOA. Okay. The second method, you can also use FOA is equal to F cos theta. Okay. So this F here is a magnitude of force of this force, which is 10.95 kilonewton. So you already calculate here. So substitute into the equation here, and then cosine theta. The theta you get also from this operation, which is 36.5 degree. So substitute into the equation, so you will get the same answer as the previous method. Okay. So you can use any two of this method.